Let's now write the code inside the switch so we can make the transition between the different states of the state machine. So we have two different triggers. First, when the state is read, the trigger will be when we press on the push button. And then for each other state, the trigger will not be something that we control from the outside, but it will simply be some time that we wait, okay, between the yellow and the green, between the green and the blink green, and between the blink green and coming back to red. So the first thing here I'm going to do is to handle this case. So the case when the state is red. So of course, first we power on the red LED. That's what we should do. And then I'm going to check the condition to see if we can actually go to the state yellow. So I'm going to do if. I'm going to do button is pressed. Okay, so we have in the button, so let's go to push button.h. We have a method here is pressed, which will return true if the button is pressed and false if the button is not pressed. So we just check if the button is pressed while we are in the state red. And if the button is pressed at any time in this state, then what we do is we do state is equal to state yellow. So then we have break, we break out of the switch, and because the update is going to be called very, very fast, we come back to the switch again. This time the state is not red, this time the state is yellow. We power on the yellow LED. And now the thing is that we need to wait. So in the specs I have given you 3 seconds. So we need to wait 3 seconds before we change from state yellow to state green. Okay, if I directly do this, state is equal to state green, what's going to happen is that we're going to enter this. And because we continue very, very fast with the update method, then we're going to enter the state green directly. So you will not be able to see the yellow LED, or you will just see it for a super small fraction of time. So here, what I'm going to do is I'm going to create some sort of timer. I'm going to create some sort of timer so we can spend 3 seconds, or at least we are not going to block the code, okay, with delay, because one easy solution would be to do this. But we don't want to do this because that's going to block the entire program for 3 seconds. So we are going to use the time functionality to simply check that from the time that we changed to state yellow and the time that we want to go to state green, at least 3 seconds have passed. And so I'm going to create in the header file, I'm going to create here, so let's do this after the state, unsigned long yellow state start time. So this name is pretty explicit, okay? This is the start time when we just trigger the yellow state, when the yellow state starts. And so I am going to initialize it right here. I'm going to do yellow state start time is equal to millis. So millis is the current time at this point of the program. So when I am in state red, I check if the button is pressed. If the button is pressed, I change the state, so the next time we enter this, and I also start the kind of the timer. Okay, so I just save the time when I actually change the state. And so in state yellow, what do? I'm going to compare the current time with this start time. Okay, this is going to give me a duration, and I'm going to compare this duration to the time I want to wait. So for example, 3000 milliseconds. So to get the current time, I can directly get the time here, or what I can do, because I'm going to use the current time in many of the states, before I use the switch, I'm going to do unsigned long time now is equal to millis. So you can name it time now, current time, whatever you want. And make sure, again, if you use millis, you use millis. If you use micros, you use micros. And in the state yellow, after I power on the yellow LED, I do if time now minus yellow state start time. Okay, and here you can see it's important that you save it globally in the class, so basically with a private attribute, okay, because you can modify it there and retrieve it there, okay, because here you're going to modify the attribute, but if you just created a variable here, this would not be the same scope as here. So you need to either make it global or make it a class attribute so you can retrieve it after you have created in that other scope. So I'm going to check if the time now minus the time when we started the yellow state is greater than 3000 milliseconds. And instead of just hard coding this, I can go to my traffic light.h and I'm going to create, so here I'm going to create a const int yellow duration, so yellow state duration is equal to 3000. So I create another attribute, but I just put const. Okay, so this becomes a constant that I can't change in the code, so I can just initialize it there. And the thing is that, so I could create just an int and initialize the yellow state duration in the constructor. But what I can do also is I can initialize, if you want to, you can also initialize directly the attributes inside, so when you declare them actually, so inside the interface. So if you use a const, that's okay. I mean, that's not going to be a problem. For other attributes, so for example, for the states, we could also initialize it here, but as a best practice is best if you don't initialize your attributes, you just declare them in the interface, and then you initialize them in the implementation. So here the state actually is not initialized in the constructor, but in the init method. So going back to this, I have my yellow state start time and the yellow state duration, which I'm going to put there instead of 3000. And so if we have spent at least 3000 milliseconds in the state yellow, then what I do is simply change the state. So state is equal to state green. Okay, and what do I want to do then? I want to stay in the state green for 2 seconds, okay, as with the specs. So I'm going to do the exact same thing. I'm going to go here and I'm going to create unsigned long green state start time and then another const int. So I could use const long, unsigned long, etc., but int is going to be fine here. Green state duration, and let's put that to 2000. And now I go back to here, and so in the state yellow, when I change the state to state green, I also do green state start time is equal to current time, so millis. And then I break, and the next time we enter the switch, we go to state green, we power on the green LED, of course, and then we start to check if time now, so the time now is here, that one. And actually what I can do is here, instead of calling millis again, I can just use time now, because I already have millis, and the time now here, so when you use millis here and here, well, this is going to be the same millis you are going to get, so you're going to get the same result. So I can just use time now here instead of calling millis again. And then when it's green, so I check, I put it green, and I check if time now minus green state start time is greater than the green state duration. In that case, I do state is equal to the next state, which is state blink green. Okay. And what I can maybe do also is, so just to use the method, I can do, for example, all off here. Because here we just change between a state where we just have one LED powered on to another state where we blink an LED. So here that should not be a problem, but let's say that you were in state yellow and you go to blink green. Imagine that you are not blinking the green LED, but you may still have another LED which is powered on. So I'm going to do all off, just so we use the method here. And now what I'm going to do is I want to stay in the state blink green for 3 additional seconds. So I'm going to do the exact same thing as before. I go to the header file, I create unsigned long blink green state start time, and let's do const int blink green state duration. Let's put that to 3 seconds. You can modify the values if you want to. I'm going to keep 3, 2, and 3 for this example. So let's go here, and when we change the state to blink green, I do blink green state start time is equal to time now. And then when I enter the state blink green the next time I enter the switch, so I'm going to call the update, which is going to do all the work here to make the LED blink, so we don't need to worry about that anymore. And I'm going to check also if the time now minus the start time for the blink green state is greater than, let's actually take that from here, the blink green state duration. And let's go back to a new line here, and let's actually do this. Okay, so it's not going to go after the max here. And then what I can do in that case is state is equal to simply the state right. So we go back to the state right. So the next time we enter the switch, we go back to this, we power on the red LED, and then what we do is we don't use the time functionality, we just wait until someone presses on the push button to continue the sequence. So the state red will be on for an infinite duration until you press on the button. And of course, then we have the default. So default is basically if the state doesn't correspond to any of the state here, which means that there is an error. So in that case, what I'm going to do simply is do state is equal to state right. So if we have an error somewhere that put the state to something that is not valid, I just put back the state to state right. So we start the state machine again with the first state. All right, so that seems to be it for the state machine, okay, which is the most important functionality of this class. So we have created here in the header file, we have created 3 attributes to keep the start time for each state. We have some constant to define the duration we want to spend in that state. And then we have a simple mechanism to check the duration since we have started the state and the duration we want. So we can kind of wait inside the state before going to the next one without using the delay function. And nothing here is blocking the code. So when you call update, it's going to finish the method. So it's going to execute super fast. So now what I can do in my main file, I'm going to remove everything from the loop. And the only thing I need to do is traffic light.update. And well, that's it. So now the main is even better because so you have some initializations, okay, with include, define, and object creation, and then 1 line of code for the setup, 1 line of code for the loop. So that's basically the minimum code you could have in your main. And now I'm first going to validate the code, verify the code to see if I have an error. And you can see, yes, I have an error here. I call all off, but it's actually all LEDs off because I haven't checked. So I can check here the function all LEDs off. So of course, if I try to call a function or a method that doesn't exist, well, that's not going to work. And down compiling. And now is the time to test this program on the Arduino board. So now you should have the correct behavior for the traffic light system, okay? Because we initialize the traffic light here and we call the update very fast in the loop, which is going to make the state machine work. So let's upload. And you can see that first we have the red LED which is powered on. So nothing happens. I need to press on the push button once. I press and you can see the yellow LED for 3 seconds. And then we have the green LED for 2 seconds and now it's blinking for 3 seconds and going back to red. Okay, so now we wait again. If I press on the push button, we have another sequence. Yellow, green, blink green, and red again. And the traffic light is working. So we have the main functionality that is perfectly working correctly. Now what we're going to do is to add the functionalities related to the potentiometer.